Show by the principle of mathematical induction that for all n belonging to the set of natural numbers, 2n plus 7 is less than n plus 3 squared. Using this, also prove by induction that the inequality n plus 3 whole square is less than or equals to 2 raised to the power of n plus 3 for all n belonging to the set of natural number. Okay, let us begin. So first, what we'll do, we will consider the mathematical statement P of n. So let P of n be the statement given by P of n such that we have the inequality 2n plus 7 that's less than n plus 3 squared. Now this is a statement which we need to check its validity. That means this statement has to be valid for any natural number that we pick up. That means any n value that we pick up where n is a natural number, this statement must be a valid statement. It always has to be a true statement. So let us proceed. So first what we'll do, we're going to check whether if the statement is true for n equals to 1 or not. Okay, so for n equals to 1, we know P of 1 that is going to be given by 2 times 1 added to 7 less than 1 plus 3 whole square. So 2 times 1 plus 7, that's simply 9. So 9 less than 1 plus 3, that's 4. 4 squared, that's 16. Yes, this is a true statement. This simply tells us that P of 1 is true. So we have shown here that the statement P of n is going to be true for n equals to 1. But we'll also need to check for other natural numbers as well. So here what we'll do, we're going to suppose that P of m, where m is a natural number, P of m is true. If this is true, that means what is the statement P of m? P of m is simply the statement 2m plus 7, and this is less than m plus 3 whole square. All we've done is take this statement Pn and replace n with m. So this is going to be statement number 2, and we're assuming that this is a true statement. With the help of the statement, our goal will be to verify that P of m plus 1 is also a true statement. P of m plus 1 is true. Now what is m plus 1 here? M plus 1 is simply the natural number that is consecutive to that of m, that comes after m. Fine. Now what is P of m plus 1? The P of m plus 1 statement, that is simply going to be 2 multiplied to m plus 1 added to 7. So all we're doing is replacing the m with m plus 1. This must be less than, we have m plus 1 added to 3 whole square. So this is essentially what we have to verify, that this is also true. Let's call it number 3. Now what we'll do, we'll take the help of statement number 2 because that is a true statement. So from statement number 2, we can say that 2 times m plus 7. So this is going to be less than m plus 3 whole square. This is a true statement. Now what we'll do, we're going to add 2 to each side of the inequality. 2 being a positive number, that's not going to change the sign of the inequality. So adding 2 to the right hand side makes it 2m plus 9, and on the right hand side we have m plus 3 whole squared added to 2. Right, let's expand this. So this is going to be 2m plus 9. This is going to be less than m squared plus 6m plus 11. Fine. Which can be further manipulated to get 2m plus 9 less than m squared, but instead of 6m we're going to consider 8m, and instead of 11 we're going to consider 16. But these are extra terms that we have added. So what we'll do, we'll have to subtract 2m and we have to subtract 5 as well, which means now we have 2m plus 9 less than m squared plus 8m plus 16. This is simply m plus 4 whole squared minus we have 2m plus 5. Now we know that m is a natural number. So m is a natural number, which means 2 times m plus 5 is going to be some natural number. So when we take m plus 4 whole square and from it we are subtracting a natural number 2m plus 5, we can definitely say that this value is always going to be less than m plus 4 squared. In other words, what we can say that 2m plus 9, so this is less than m plus 4 whole squared minus 2m plus 5, and we are saying that m plus 4 whole squared minus 2m plus 5, this is also going to be less than m plus 4 whole squared. In other words, we have 2m plus 9, so this is less than m plus 4 whole squared. So we're almost there. We can rewrite this expression as 2 times m plus 1 added to 7. So this is going to be less than m plus 1 added to 3, and we squared it. So this is exactly what we had to show in statement PM. So since this is coming out to be true, this simply tells us that P of m plus 1 is true. Fine. So we started out. Thus, we say that we started out with the statement that P of m is true. We started out with assumption that P of m is a true statement, and with the help of this statement we are able to show that P of m plus 1 is also true. This is also a true statement, which means that by the principle of, we can say that hence, by the principle of mathematical induction, the original statement P of n, the P of n is always going to be true. This is going to be true, and is going to be true for all values of n belonging to the set of natural numbers. That means any natural number that we pick up, the statement P of n, and P of n, this is simply given by 2n plus 7 less than n plus 3 whole square. This statement is always going to be true. So here we have successfully proved the first part of the problem. Now let's come to the second part. Now using this, we have to go and prove by induction that n plus 3 whole square is also less than or equals to 2 raised to the power of n plus 3 for all n belonging to the set of natural numbers. Okay, so let us begin. So this time we're going to consider a new statement. So let's say let the new statement be denoted by p prime n such that we have n plus 3 whole squared. This is less than or equals to 2 raised to the power of n plus 3. So this is our new statement. So let's call it statement number 4. Fine. Now we will assume that p prime of m, this statement is true. Now what is p prime of m? P prime of m is simply replace n with m to get m plus 3 whole squared. So that's going to be less than or equals to 2 raised to the power of m plus 3. So this is number 5. So we are considering a new statement p prime of m, and this is a true statement which is given by m plus 3 whole square less than or equals to 2 raised to the power of m plus 3. Now using this, our goal will be to verify that the statement p prime of m plus 1 is also a true statement. Okay, so let's try to do that. So p prime m, what is p prime m plus 1? P prime of m plus 1 is simply going to be replace this m value with m plus 1 such that we get m plus 4. We have to show that m plus 4 whole square, that is less than 2 raised to the power of. So replacing this m with m plus 1 gives us m plus 4. This is what we need to show. Okay, now using statement number 4, since 4 is a true statement, using statement number 4, we have m plus 3 whole square. So this is less than or equals to 2 raised to the power of m plus 3. Fine. Now what we'll do, we are going to expand m plus 3 whole square. So that's going to give us m squared plus 6m added to 9. So this is less than or equals to 2m plus 3. Now let's do one thing. Let's add 2m plus 7 to both sides of the inequality. So we have m squared plus 6m added to 9 plus we have 2m plus 7 added to both sides of the inequality. We have 2 raised to the power of m plus 3 added to 2 times m plus 7. Now this is done because what we now get is m squared plus, so 6m plus 2m, that's going to be 8m added to 9 plus 7, so that's 16. So this is going to be less than or equals to 2 raised to the power of m plus 3 added to 2m plus 7. Fine. So m square plus 8m plus 16, this becomes m plus 4 whole square, which actually gives us the left hand side of the inequality of p prime m plus 1. So that's the reason why we added 2m plus 1, 2m plus 7 to both sides of the inequality. So we have m plus 4 whole square. So this is going to be less than or equals to 2 raised to the power of m plus 3 added to 2m plus 7. Fine. Now we have m plus 4 whole squared less than or equals to 2 raised to the power of m plus 3. Now, we have already shown that 2m plus 7. So here we have already considered in statement number 2 that 2m plus 7 is less than m plus 3 whole squared. So if this is less than m plus 3 whole squared, so here what we can say? We can say that m plus 4 whole squared, this is going to be less than 2 raised to the power of m plus 3 added to m plus 3 whole squared. Fine. So here we have using statement number 2. Fine. So what was statement number 2? Statement number 2 stated that 2m plus 7. So that's going to be less than m plus 3 whole squared. Fine. Next, we have m plus 4 whole squared less than or equals to 2 raised to the power of m plus 3. Now what is m plus 3 whole squared? Now m plus 3 whole squared, this is also less than 2m plus 3. This is nothing but statement number 4. We have considered statement number 4 to be a true statement. Statement number 5 actually. Statement number 5 to be a true statement. Let's write it down. From statement number 5, using statement number 5, where we have stated that m plus 3 whole squared, that this is less than or equals to 2 raised to the power of m plus 3. So here what we can do, we can replace this m plus 3 with 2 raised to the power of m plus 3. Finally, we have m plus 4 whole squared less than or equals to, now both of them are the same term, so we have 2 times 2 raised to the power of m plus 3. So we now have m plus 4 whole squared. So this inequality, this is going to be less than or equals to 2 raised to the power of m plus 4. So we have successfully showed that p prime of m plus 1 is also true. This is also true, and since this is true, therefore by the principle of mathematical induction, the statement p prime of n, the p prime of n was n plus 3 whole squared less than or equals to 2 raised to the power of n plus 3. So this statement is a true statement, and it is going to be true for all values of n belonging to the set of natural numbers. That means any natural number that we pick, the statement p prime of n is true. Hence proved.